Hello, this is Mr. Buffington from Simplify Academy, and today we will be multiplying decimals again. We've done this one time, now we're going to do it again. Let's take a look. We'll multiply decimals. It's going to be a little more complex than the last lesson when we multiplied decimals, so we are going to need to practice. Let's start. Quick review. With the previous lesson, we did questions like this, 1.5 times 2. And we would rewrite it ignoring the decimal, right? We would just rewrite it as 1.5 times 2, pretend the decimal's not there at all, and just multiply like normal. Like 15 times 2 is 30. Okay. Then we go back and we count the digits on the right of the decimal. In this case, we have a 5. That's the only digit on the right of the decimal, so that's one digit on the right of the decimal. Then our final answer, 30, needs to have the same number of digits on the right of the decimal. So we will have to put a decimal right there between the 3 and the 0. Notice our final answer has one digit on the right of the decimal, and in our multiplication question, 1.5 times 2, we have one digit on the right of the decimal, that 5. That will be consistent. Now we're going to make it just a little bit more complex, not that bad, but we're going to have numbers like this, 1.5 times 2.1. We're going to follow exactly the same steps. We'll rewrite it, basically ignoring the decimal when we do the multiplication. So we have 1.5 times 2.1. We're going to treat this like 15 times 21. We'll multiply that out to get 315. Then we do the same thing where we count the digits on the right of the decimal. But in this case, we count all the digits on the right of the decimal. So we have a 5 in 1.5, and we have a 1 in the number 2.1. That is 2 digits on the right of the decimal. So our answer should have the same. It should have 2 digits on the right of the decimal. And that means we have to put the decimal here. So we have 3.15. It won't always work out to have the same numbers, that it's a 5 and a 1, but it will always work out to have the same number of digits. So let's practice. And we're going to start working with larger numbers like this, but we follow exactly the same steps. So try that one out. You're going to want to rewrite it, remembering to ignore the decimals and just multiply like normal. Then count the number of digits on the right of the decimal. Make sure that's the same in your final answer. Go ahead and set that up, multiply it out, and come back to the recording and see what I got. Hey, welcome back. When I multiply 431 times 112, I get 48,272. It's a big number. Now what I need to do is count the digits on the right of the decimal inside of the question. So I have a 3, a 1, and a 2. That's 3 digits on the right of the decimal. My final answer is going to have 3 digits on the right of the decimal. Therefore, my answer is 48.272, or 48 and 272 thousandths. I want you to try this out. Lots of practice for this. It's going to give you a really big answer at first, but then we'll move those decimals in. Try it out. Welcome back. I am going to rewrite this ignoring the decimal and pretend that this is 1,122 times 105. I'm just going to pretend the decimals are not there and multiply it out. Normally, if I was doing this by hand, it would take several steps. I don't have the room for all of that, but what I ended up with was 117,810. But that's not really my answer, right? I'm multiplying 1 times 10. So I can pretty much guess where my decimal is going to go. Let's take a look. I count the digits on the right of my decimal, and my final answer should have the same number of digits. So there's a 1, a 2, a 2, a 5. 1, 2, 3. That's 4 digits on the right of the decimal. My decimal is going to go right there for my final answer of 11.7810. This is an interesting case where you end with a 0. When your decimal ends with a 0 like that, you can rewrite it without the 0 on the end. That's perfectly fine. We do that with money all the time. $20, we usually don't write 0.00 on the end of it. So that was our lesson. Couple things to remember. You ignore the decimal, multiply like normal, and then count the digits on the right of the decimal so your final answer has that same number. If you got an extra 0, you can get rid of it. Or if you've got an extra 2 zeros, you can get rid of those too, I suppose. I hope that lesson was helpful for you. Have a wonderful day.